Hello, welcome back. My name is Chris Dale, and today I have yet another video from Over the Wire, and we're going to be solving level 26, where apparently we'll be drawing something. So let's see what happens when we put in some coordinates here. Like 1, 1, and 100, 100. Drawing a line. Sure enough, we can draw a line. Cool. What if we were to put in something like this? Oh, cool. So basically we can create lines. And we can see the get parameters up here in the URL. They're being put in. So I'm guessing anytime I send this in, we're going to be drawing the same type of drawing. Sure enough, we can even make it draw more stuff. So I just gave it X, Y, Z. That's interesting. What happens if I put in like, this is probably not a drawing challenge, but you can see we can make some interesting drawings here. But alright, so is there anything to hack here? Image line expects parameter 2 to be long, string given in. Alright. Let's take a look at behind the scenes in our HTTP history here. So this request, we draw some lines. We can see a very interesting cookie. Ooh, look at this cookie here. So this looks like it's base64 with a URL encoding at the end here. You can see the %3D, which represents an equal sign. You can see the base64 encoded information here. I can make an assumption that it's base64 based on the character set. It contains upper lowercase characters all the way from A to Z, and also some numbers in here. We might even see some special characters, but I don't see any right now. But we definitely want to decode this and see what's behind it. For that, I'm going to be opening our dear friend, CyberJeff. So CyberJeff is awesome. We're going to be drag and dropping this in here. Actually, let's do this into a new tab. Let's keep this old tab here. And we're going to be here, copying all of this content into here, the basics for decode. First of all, though, we need to URL decode these %3Ds. So I'm going to do URL decode in front of them, so it takes care of this. Notice that this URL decode, it just takes care of the padding at the end here, so that the string will finish off neatly. So now we have this array of lines, and this is so this is what the application is doing then. All right, so it serializes something here. This is object serialization. This is basically a serialization, so a representation of a PHP array of 4 in length, where the first array is going to be another array containing 4 elements. So the first array, index 0, is going to be an array containing a string of 2 of size called x1. So this is the x1, I1. So it contains our drawing. And it contains all the lines that we want to put into this drawing. So we could basically, we're sending this through in a cookie. So that's how it preserves state from one request to another, it seems like. And every time we visit this page, yeah. So you see in the storage here, you can see the drawing cookie. This one is just going to keep on growing as we're putting more lines into this drawing. And the back end is going to take this cookie here. It's gonna go to CyberJeff here. It's gonna base64 decode it, and it's gonna see this serialized object here, and then it's gonna deserialize it and create this drawing, most likely. And I'm gonna guess that the vulnerability has something to do with object serialization, because that's something that is really dangerous. But it can also be extremely hard to exploit if we don't have access to the source code. Because if you don't have access to the source code, you need to make assumptions that are using some kind of library or something that has a class, an object that you can make them deserialize. And inside of this object, you need to have it either initialized, or you need to run a magic function like a constructor or a deconstructor, or some kind of magic function within PHP that causes your code to execute. For example, a constructor would basically, in a class, a constructor would allow you to basically, for every time this class is initialized, we're going to run through the constructor. So that's kind of like code execution for every time an object is initialized. And those type of things go really well within object serialization vulnerabilities. And but the problem is knowing what objects are in the backend. What type of objects do we have to play with? So black box type of testing in these cases can be really hard. There's been plenty of vulnerabilities within object serialization issues. For example, the big one that I can come up with right now was the Apache struts vulnerability where they basically found a gadget within a chain of libraries where they found like this gadget, we call it, that allowed you to basically, if deserialized, would allow you to get your code to execute. The nice thing about Over the Wire, though, is that we do have the source code at our disposal. So in this challenge, I'm going to take a look at source code instead of trying to fuss this to see if we can break it with in a black box perspective. I think that will be hard. So instead, let's take a look at the source code. You can see that we have a class, logger. Seems to end down here. You can see that we have 3 private variables. You see we have a constructor, a destructor. Now, these are magic functions. We call them magic functions. They do something magically or behind the scenes. And it seems like they're logging to a temp directory some log information, session start, session end. And they're logging here, that's fine. Then you have show image, you have draw image from user data. So this is when, if you have the array key set in the get parameters, this is when you submit a new drawing or a new line, it will be creating this image for you. And, ooh, yeah, this is where the problem is. You can see this unserialized function, base64 decode on the cookie, and then you unserialize, basically you unserialize this. And I can control this value, right? I can control my own cookie. I can go into my own cookies and change them to be whatever I want to, and they're simply gonna unserialize my cookie. You can also see unserialize being used down here. You can see serialize being used here to put back into the cookie. All right, so that's cool. And I think that seems to be what we need to look at here. Down here we have basically the starting of the image and the starting of the session and so on, drawing a session. You also see a folder being used here, /img, and they're creating a PNG based on our session identifier. That's pretty interesting. So basically, this image here should be in the img directory then. Yes, based on our session ID up here. All right, so I can, this is a user control value as well. I can control that one. I'm not sure if I could use that to do any directory traversal type of things though, but I think I'm going to go with the serialization issue. It's been years since I solved this, and if I remember correctly, it was the serialization on this class. All right, so let's go explore this inside of a Linux VM. Now, what I want to explore now is I want to recreate the target environment, and it's all PHP, and PHP is very easy to install and use. And on my Slingshot VM here, I basically can run PHP code very easily from the command line. So I'll just do a simple create directory, and I'll create a file called natas26.php, and I'll paste in all the source code from the target website, and then I'll run this source code on localhost port, say for example 1508. All right. So let's open up this web server now and let's see what's up. Let's go to 1508 natas26.php. Now we can draw a line. So let's do it one more time. Draw, and it didn't work. And this always happens when you try to recreate a target environment. It might not always work. There's error messages, so on, you need to account for. But the beautiful thing with PHP-S, it allows you to run a local web server on your system that supports PHP code and libraries and all of that stuff, and it shows you the error messages in the console. And look at this. The image PNG function gave a warning, failed to open stream, no such file or directory in home slingshot natas 26. Right, because we don't have an img directory. Let's fix that. Do one more time. And just like that, we created the directory img, and now it could write this file, and all of a sudden we get our stuff working. So, deserialization. Now let's experiment with the logger class, right? Because we had the logger class here, and I can input a logger class for them, and as long as they use this function or in any way the constructor or destructor is being used in the code, we can potentially get code execution that way. So what I'm going to do is I'm going to see how this logger looks like when it's been serialized. And I'll do that inside of my VM here. So first of all, let's copy Natas to Natas2. So I have a working copy here. And we'll do, let's go to line 1. Expand on this a little bit. So here we have the class logger. We have init message, exit message. Fine. We can keep all of this. Log file. Kind of want to rename this one to home slingshot Natas. In fact, let's call it in the imp directory because I know it's writable. Just because I don't want to be operating from temp directory in any way, just in case here. Then we have all of that stuff. I'm going to go to the bottom using Shift G, and I'm going to say test equals new logger like this, and then I'm going to say print R. So I'm going to echo out to the user. I'm going to echo out serialize on the test object. See what happens now. So I'm going to copy this, new tab, Control T, to the PHP, and there is no base64 down here. Why not? Well, let's check the log then. It says that, oh, you can see that it tried to fire up my constructor. That's beautiful. That's a good sign, but it failed because too few arguments to the function logger. Oh, the constructor is expecting an argument, 0 passed, and it expected 1. All right, so that's beautiful. It basically tells us what's wrong. Let's fix what's wrong. And what's wrong is that apparently this new logger expects an argument. So let's go to up here. And this is where we see the bug here. Yeah, so this is not the bug, sorry, my bug. Function constructor accepts in a file name or a file. So you can see, oh yeah, this one. It goes in here. Natas26 variable file. All right, so let's just give it that parameter then. So let's do here, new logger. Let's serialize this one. See what happens now. Control R to refresh. And now we have a beautiful little object. Now what are we looking at here? We're looking at, just so we're clear, we're looking at the serialized version of the logger class. That's what we're looking at. You can see that it's a type of object, 6 in length. Its name is logger, and it has 3 items in it. Now, when you serialize objects in PHP, let's just go in here and look at it. PHP object serialization. When you serialize objects in PHP, they don't serialize the methods, only the constructors and deconstructors and so on. So you can see that serialize returns a string containing a byte stream representation of any value that can be stored in PHP. And unserialized takes that value and composes objects and whatever you need to do it, or whatever you need to use it for. So pretty nice. In order to be able to use unserialized, the class of the object needs to be defined. You need to have a class A and serialize this, blah, 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 blah. All right, fine. Pretty nice having an online manual. So let's take a look at this one now. We see logger, log file, home slingshot Natas. You can see the AutoCAD is being put in here as we expected. All right, so the constructor and this deconstructor is not part of the serialized message. So naturally, yeah, of course not, because it needs to be defined in the backend. You need to know which classes are defined in the backend. So what I'm going to do is I'm going to take this message here, and I'm going to try to create something hackety-hack in it. So I'm gonna add some stuff to it. For example, let's go to line 1 again. for example, exit. What if, ooh. So we can write into this file here. What if we name this PHP? And what if we put in PHP code here? Let me use single quotes here so I don't have to worry about escaping. So I'm gonna make this PHP echo hello world, and it's gonna be named Natas26 AutoCAD.php. One more time, let's serialize this. All right, so the exit message. Okay, so the exit message is actually PHP code now. That's why it's not displaying anything there. Make sure that there's no bugs. Okay. I don't like that. Why does it not show anything? Oh, is it because we're looking at the source code? Okay. So you see, I think it's because it's actually interpreted as HTML. So it's just my browser, my client being a bit messy here. So let's fix that by basically doing a basic64 encode here. Because after all, we're going to be using this as a basic64 attack. So it's going to be basic64 when we launch the attack, I mean. So now I have a basic64 string. And let me give that to the original script here. So let me press F12, go into the storage here, and I'm going to be overwriting the original cookie of the drawing. So I go here, paste in my own cookie, the one that I have created from a serialization and a basic64 encode. I press Ctrl R to refresh the website. Okay, and it just drew the lines from this up here. I don't want this. I'm going to remove that. And I'm going to be, just because I want to control the backend code a bit more, I'm going to put in this here. Now I'm going to press Ctrl R to review, to refresh the web page. Just because I want to control the flow of logic, I don't want to introduce any more complexity than I need to here. So let's check the error logs. Store data. Cannot use object of type logger as an array. Okay, that's interesting. So try to use my class. In fact, ooh, yes, it did work. Even though it threw a notice here, a 500 error message, it did actually create a Natas26 AutoCAD PHP file here. And it says hello, echo hell world. So something is happening behind the scenes for sure. We're basically doing code execution here, because if I now went to go here, I take this URL here, I go to /img, and I do Natas26 AutoCAD.php. Hello, you can see the code is being executed on the target server. So that means we have a way of solving this challenge. And what's the goal again? The goal, of course, is to get the flag for the next level. And the flag for the next level, they are stored in, wasn't it in var natas webpass natas27? I think so. Let's start with this. And also we need to read a file, PHP read file. This is coming from, by the way, this knowledge here is coming from the previous levels. So you see some hints on where to get the flags and where to get the password from the previous levels. So read file, blah, 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 blah. Is this the best way to read a file in PHP? I guess so. Let's trust Google. All right. So why don't we do echo read file like this. What if this here is our source code? Read file. And these are optional arguments. Writes it to output buffer. So can we do this? Looks like it will work. Just a bit cautious about read file. I thought it was called something else. PHP echo content from file. Just one more query here. Just make sure that we have the source code correctly. Oh yeah, I like this one much better. File get contents. Oh yeah, yeah. Reads the entire file into a string. Yeah, I think this will work better actually. So let's do this. Go back into our slingshot. Now we'll do Natas 2 here. So I'm gonna now put this into where we have our code execution. And that's gonna be in the beginning of the file. So let's go to line number 5, Shift G. Here. Up here, I'm gonna put in this value here. Shift V. Var Natas web pass, Natas 27, file get contents. We write. We take this here, refresh this website. Do we have an error? I think we have an error. So let's just double check PHP exit message. Am I in a, oh yeah, written to. So is this in the wrong file? So where is our base64 encoded output? I'm just gonna make sure that we got the correct here. All right, so cannot use objects of, ooh, I know what's wrong. We're submitting our cookie now. We're submitting the attack. So I need to basically delete all of these so that the correct portion of the source code is triggered. Now you can see that I have a base64 string. This string here is the one we want to submit to the real solution. So what we're going to do now, we're going to update our cookie here. See what happens. Actually, I think I had an extra, yeah. So refresh the website. It should clear out this one. We see some error messages. Oh yeah, this of course needs to be fixed. Failed to open stream because we have some previous elements there. So it looks like the attack might work. So I think we're on the right track. So let's go here. The log file should of course be the original one. So let's see what the original one was. Natas. This is why we use a working copy. So the original one was, isn't it temp something? Temp Natas 26. Yes. And we want this to go into the web server. It needs to be accessible from the web server. And where does the web server, let's see where the images are stored here. Let's go to img. Where did we see the img? Store data. It's probably somewhere in the store data function here. /img. All right, so we're just going to do it like this then. We're going to use our relative file path because I can't remember where on the target web server the web server is storing files. So we'll just do like this. Write, refresh, new cookie, copy paste, back to this, update here, refresh. That looks better, and there are some errors with offsets. That might be fine. Let's now go to the img directory. Img. Let's do Natas 26 AutoCAD.php. One more time. What was it called? Natas 26. Yes. Should be like this. Natas 26 AutoCAD.php. But it's missing, so something happened and it wasn't written. So let's see what's happened here. Unserialized error at offset 148. Alright, so it's basically giving us on line 70 of the index PHP. Let's go there. It's already open here. So we're gonna go to 76, I believe I said 76. So here we have, Actually, double check that. Line 70. Here. Unserialized. So it has some bad offsets. And the bad offsets, basically, normally that means that within this string here, I would assume that this means that we have some errors in the lengths of the strings. So here you can see that it's a 6 length here, and the string should be 15. .logger. Now here's some funky business here. This is funky business. It used to be called logger something else. And right now it's called .logger, and it has some funky stuff going on here. So I'm thinking that this serialized message that we're getting from the solution from our Natas 2 might have some funky business due to relative file paths. So I'm just gonna double check the source code here. Let's go to the beginning, and the logger here. Now this is a problem. Here. This is the wrong file. Here. So we change this to img. That's fine. Echo file contents. This one needs to be, the exit message should be a long string. Do we see this long string here? Yeah, 63 of size. So this is probably 63. I see what's up. You see there's no ending here. There's no end of the PHP here. So that's our problem, I'm gonna assume. Why is there no end? Is it because we didn't copy the entire string, maybe? This is the fun part about hacking, right? There's so many mistakes to be done, and you're always curious, is this mistake because of me? Is it because of the solution? What's going on here? Let's try one more time now. I just fixed my copy paste issue there. I'm gonna overwrite, press Ctrl R, and now it looks much better because I don't get the offset error messages anymore. Let's go here and pay to OpenStream. So this is working, yes, but it's not there. Ooh, it's not in var, it's in etc, I believe. So right now we have code execution. You can see that it tried to open up the file. Beautiful. All we gotta do, hopefully, to fix this challenge is to say, instead of var, it's gonna, I think it was called etc. Right quit, or just write, Control R, take the updated base64 string, and I can feel the end is near. I think we're gonna get this now. We're gonna go here, paste in this entire thing here, make the code execute by refreshing the website, refresh this one, and just like that, the password for the next level. Yoo-hoo! Let's see what's up. 27, if it works or not. Natas 27. And sure enough, we're at level 27. Now this is for the next video, guys and girls. Hopefully stay tuned for the next video. I'll see when I can make the time to create it. I hope you liked the video. Leave a comment below if something was unclear or if you liked it. I very much appreciate your comments. It warms my heart. And stay tuned for the next one, okay? Bye-bye. Thank you very much for watching.